A very good day. We are from MEMS 18. This is our video presentation.
Good day everyone. This is our MEMS thermal IR sensor device which is used to detect the temperature based on the deformation of the top cantilever. This device contains three parts, which is fixed support, which is made from silicon substrate and structural steel, upper part cantilever, which have bimetallic that made from gold and titanium, and a silicon carbide. For the lower part is a fixed capacitor electrode, which is made up from titanium. This is the dimension for our device. When the heat is applied on the top upper part, deformation happens, and the upper part cantilever will bend down and change the gap between the two metal plates, which have an effect on the capacitance that is used to convert the electrical signal proportional to the amount of the heat absorbed. The output voltage of this device indicates the temperatures detected by the device. Next is the demonstration video of our device. As you can see, when heat is applied, deformation happens and it will bend down. Next is the simulation result for temperature.
A very good day. So for our device, we have tested with three parameters, which is temperature, material, and also the thickness. So for my part, I will be doing the temperature. So as you can see on the slide, three different temperature has been tested on the device, and the results are obtained and as shown below. So the chosen temperature is based on the temperature set by the Health Organization to counter against the COVID situation. So at the right side is the tested of the simulation of three temperature. We You can see the have a maximum deformation of 0.00345 for temperature 36.5 and 0.01036 for temperature 37.5, and the last one is 38 degrees Celsius, which have the maximum deformation of 0.0138. So an overall, the higher temperature will have a much more deformation. So that's for my part. Next will be the material.
For the simulation of material, the temperature is fixed at 36.5 degrees Celsius, while the test material is fixed at the thickness of 1 micrometer. The test material used are titanium, copper, and zinc. Based on the result, we can see that the highest maximum deformation for material is zinc, which is 7.7162 10 times power of -3 micrometer. Higher deformation give significant change of the gap between two metal, and it will not break easily. It also provides a significant change of capacitance and generate a great output voltage for this device. Next will be the simulation for the thickness.
Hi, next, different thickness for the cantilevers of the MEMS infrared sensors is used to obtain the maximum deformation of each thickness. During the simulation, by using ANSYS software, the input used is the thermal condition with a fixed temperature of 36.5 degrees Celsius and the fixed support for the MEMS infrared sensors, and the output is the total deformation. All the materials for the MEMS infrared sensor used is the same for all the simulation. The thickness of cantilevers used is shows in top left figure will be increased from 5 micrometers to 11 micrometers as shown in the table. An animation of the MEMS infrared sensors with thickness of cantilevers of 5 micrometers is shown at the top right videos. The maximum deformation obtained for each thickness of cantilevers is shown in the table where if the thickness of cantilever increase, the maximum deformation will decrease. Thus, the thinnest cantilever, which is 5 micrometers, which has the highest maximum deformation, would be the most suitable design for the MEMS infrared sensors because it has significant change in capacitance and has large power output. Next will be the application for COVID-19.
A very good day. So our device, as we know, is used to sense temperature. So it is able to help in the situation of COVID-19. So this device can be applied to everywhere. The majority will be used in the shopping mall, shop lots or hawker store. But it is also able to use for the houses. So this device is used to detect the temperature of an individual before they entering the shop, the mall, and many more. So, and this device are able to tell whether the individual are in low risk or high risk based on the deformation of the sensor itself, which have been stated just now. The temperature is depends on the is based on the deformation of the top cantilever. So, as we know in Malaysia, for those who are temperature have 77.5 degrees Celsius and below are able to enter to anywhere and counted as low risk. And for those which have temperature above 37.5 are not allowed to enter to any shop and is considered as high risk. So in this temperature is able to help to prevent the individual which have a higher we have a temperature which is above 37.5 degree from entering to limit the spread of the disease. So this the function of this device are able to help in the situation condition. So as a conclusion, we have tested with three parameters. So we have chosen the material, the thickness, which have the highest deformation, because higher deformation is means that the sensor will have a higher sensitivity, so that when they measure the temperature will yield a better accuracy result. That's all for my presentation. Thank you.